Hi everyone, finally I've managed to assemble a skid steer loader. I decided to release this video specifically after all the work was finished, for fear of doing the same thing with buggy on the tracks last time. Now that everything is done, and the skid steer has passed field control test, we can release the series where I'm gonna describe the entire assembly process. So don't forget to subscribe to the channel in order not to miss it. I scoured the whole internet searching for homemade mini loaders. There are lots of good ideas, but I liked neither of them in general. I decided to process all the ideas through my mind, fill them up and make something on my own. I also noticed that only a few of creators filmed the assembly process. Basically, everyone shows a finished version of their device and makes a video review. I understand full well that it's very difficult to do something and shoot it at the same time. So here, most of the spare parts for the skid steer were left from the last project, and all the used metal was pre-owned. Started my work from the platform. This is a frame around which the entire skid steer loader will be built. I'm gonna weld it using the steel profile of 18 centimeters. Before welding, we fitted two sets of wheels of our 13 and our 14 diameter to the steel profile. First I tried on our 13. They are small of course, but will be useful if the skid steer cannot turn its large wheels. Then I tried on the R14 wheels and chose them for now. I also left some space between the wheels so it'd be possible to put the wheels of some larger diameter. In the future, if funding allows, we'll be able to buy those specialized wheels for the mini loaders. But since the project is budgetary in a sort of way, I'm gonna use the ones from the car for now. I cut off 2 pieces per meter from the steel profile. This will be the right and the level side. We need to attach 2 hobs from the front-wheel drive car on each steel profile. I tried the hobs to the steel profile. I'm gonna saw off the cast steel rear clevis of the strut so it won't interfere. All the same, the hob has enough mounts. It turns out that the hob has 4 mounts, and the 5th will be welded later. I put the wheel onto the hob. It turns freely and nothing interferes with it. I started with a lower mount. It's gonna be a 10mm slab. Probably, it's not so important for a skid steer loader, but I want the wheels to be parallel to the frame. I aligned the hobs according to the steel profile plane. By the way, this is the 5th mount, which I welded almost at the very end of the assembly. I marked and drilled the next 2 mounts. We need to make some backup material for them. We managed to find a nut with a washer in size. After fastening the hob, we need to cut the holes for the drive shaft. I did it using a drill and an angle grinder. I'll need inner and outer drive shaft from the drive. They'll be welded between each other like this. The splines of the inner drive shaft will interfere, so they were immediately sawed off. There'll be a chain gearing. I welded a driving sprocket from an IZH motorcycle to the drive shaft. I'm gonna center it in place. It's convenient to do using a welded wire. In fact, it's the same drive shaft but without the coupling shaft, also with a welded sprocket. The same construction was made on the other side, but the sprocket will be welded off-center from the first one, as there'll be two chains. One side is completely ready. Now we need to prepare the second side as well. The width of the frame was determined real simply. I measured the width of the armrests of my computer chair and added another couple of centimeters, so I won't touch the cab with my elbows while controlling the leverage of the skid steer. After the size calculation, I still decided to check it in practice. For this purpose, I previously welded two boards to each other using a square pipe. Then I fastened the wheels to their place and lowered the trolley to the floor. It's quite comfortable to sit there. There is enough width in reserve. The only thing I didn't like was that the sprockets turned up to be lower than the steel profile. I decided to turn the trolley over. Now the mount got a top. It's even more convenient to unscrew from now. In such position, the sprockets are hidden behind the steel profile and we can get a flat floor. From above, the chain gearing will be covered with a steel casing. The clearance was about 17 centimeters high. I immediately closed the front part with the steel profile element. However, we need to think of the back part to try on the engine and the boom arms. But that will be in future, while now I'm installing the hydraulic oil motor. I took the same two hydraulic motors that we used for the buggy with tracks. After the last project, there remained the drive flanges. We need to cut them off and leave just the couplings. The platform for them will be made of the same channel bar. It didn't fit in from above, so I had to push it from behind. They stand perfectly edgewise and don't interfere with each other. The two sprockets will be welded to the remaining couplings on each side. The distance between the leading sprockets was determined on level. It was just right up for this case. I removed the inner splines from the sprockets right for the coupling size on the motor shaft. Was wondering what ratio to select, so I decided to set the sprocket for 17 or 15 teeth. Tried to measure both. One might take some smaller star. The only thing that matters is that the chain doesn't touch the clutch. I made a hydraulic motor mount before attaching the sprockets. Then I immediately came up with the sprocket. Only the 15-tooth variant fits the hole. If there are more teeth it won't do. Of course, it's possible to put on a 21-tooth type, but while removing the hydraulic motor we'd have to remove the coupling with the sprockets or the entire mount, including the engine. I welded the sprockets in place with cooling, in order not to burn the filler block. The ratio turned out to be almost 1:3. After the chain fitting I immediately shortened it until the desired size. I want to make a stretch in one place using a roller. The roller will pull two chains at once. This requires the hydraulic motor platform to be mobile. I wanted to make the roller of the rear hub and the sprocket welded to it, but changed my mind, as its attachment to the frame would be difficult. It was also not clear if it'd be able to tense the chains normally. I made the tensioner in another way using the rear hub. The chain tension will be like in a motorcycle. We're gonna use a rear wheel and a chain tension bolt. I removed the rear hub and bored every hole that attached it. Then I welded the bolt to the platform and got an adjusting screw. Now, while the nut tightening, the rear hub moves back, pulls the hydraulic motor and tenses two chains at once. The hydraulic motor mounting lacks the rigidity. I decided to weld another mounting spot to it. Now the hydraulic motor is holding tight. The wheel platform with the hydraulic motors is now ready. To test it, we need to connect the hydraulics. That's all gonna be in the next part. Thanks for watching and see you in the next episode.